Hi everyone. So just to continue with what we've been doing, we're going to talk about actually making conversions using the unit conversions that we learned about in the last video. So just as a recap, remember that we learned about the mole and how the mole is not this animal that burrows in the yard, although it can be used for that. It's actually a unit that scientists made up to represent this number of particles. Now remember, particles, okay, that's the sciencey word for things, can represent atoms, molecules, formula units, or ions. Okay, and so remember, atoms go with elements, okay, so it's just a pure element, whereas molecules refer to covalent compounds. And formula units refer to ionic compounds. Okay, so all of these things, and so what we've drawn here is this mole map. One other thing that I forgot to mention is that 1 mole of a substance always takes up 22.4 liters of space when it's in a gas form, and so that's another conversion. We won't really use it much this unit. We'll really talk about that actually in our last unit in with gases. But so we're going to have this mole map here. And so let's go ahead and talk about that. So if you look at this mole map, if you start out with moles and you need to get to particles, right? So either atoms, molecules, or formula units, you're going to use Avogadro's number as your conversion. But if you need to get to grams, you're going to use your formula mass, which is just another word for your molar mass that we learned how to calculate last time. So we're going to use those two conversions mostly to make our changes. So let's look at one-step conversions. So this is when we're going to convert from moles to either particles, grams, or vice versa, but we're only ever going to move one step in the mole map. So if we look at this problem, number 1, how many moles are equal to 2.4 times 10 to the 24th atoms of copper? Okay, so we see that this right here is what is given to us in the problem. So, sorry, my little thing is messing up. This is given to us, okay? So what we're going to do is we're going to start off by writing that in our t-chart. So we have 2.4 times 10 to the 24th atoms of copper. Okay, notice I'm including the element in there, and that's because when you do dimensional analysis, you can change one of two things. In this unit, we're going to only be changing the units, but next unit, we're going to learn about how you can either change the unit, in this case atoms, or the compound, in this case copper. Well, it's an element, not a compound, but you know what I'm saying. And so we're going to just get in the habit of writing down the substance during this unit. So we have 2.4 times 10 to the 24th atoms of copper, and what we know is that they want to know about the moles. And so remember, whatever unit goes here also has to appear down here. Okay, we learned about that with our dimensional analysis practice. So if we know that atoms have to come here, and what we want to know are moles, we know that Avogadro's number is 6.02 times 10 to the 23 particles, which again can be atoms, molecules, formula units. Any of those things are equal to 1 mole. And so we're going to put that in our conversion factor. We have 1 mole of copper for every 6.02 times 10 to the 23 atoms of copper. Notice copper is still staying the same, but it's my units that are changing from the top here, or excuse me, from the top to the bottom. Okay, so now we multiply across and divide by what's on the bottom. So in my calculator, this would be 2.4 times 10 to the 24 times 1 divided by 6.02 times 10 to the 23. And when we do this, we will get 4.0 moles of copper. And now the reason why that is because atoms cancel out, atoms of copper cancel out with atoms of copper, and so all you have left is moles of copper, and that is what they wanted you to find. And since my number has a number, a unit, and a substance, I know that I have my final answer. Now, if we look at number 2, what is the mass of 6.2 moles of K2CO3? Okay, this problem is a little bit different. In this case, if we were looking at our mole map, we're starting out at moles, and we need to go to mass, or grams. Okay, so that means we're going to need to use our molar mass as our conversion, because remember, molar mass is equal to your 1 mole. So over to the side here, I'm going to calculate our molar mass. So we have potassium, carbon, and oxygen. We have 2 potassiums, 1 carbon, 3 oxygens. We're going to multiply them by their mass on the periodic table. Potassium is 39.10, carbon is 12.00, and oxygen is 16.00. So if I multiply through, I'm going to have 78.20, 12.00, and 48.00. And added all together, you'll have 138.21 grams. Okay, so that means 138.21 grams is equal to 1 mole. So we're going to start our conversion chart, our T-chart, with what's given to us, our 6.2 moles of K2CO3. Now, I didn't forget the E in moles. The abbreviation for mole is really to just drop the E. I know that's not much shorter, but just so that you see that there. So whatever unit I have on the top, I put in the bottom, and so I'm going to have moles of K2CO3, and I know I can either go from moles to particles or moles to grams. In this case, I want to go to grams, and so I'm going to put my next unit, grams of potassium carbonate, on the top, and I'm going to fill it out. I know that 1 mole is equal to my molar mass, which is 138.21 grams, and I'm going to multiply across the top and divide by what's on the bottom. So 6.2 times 138.21 divided by 1, and that, if I look at what cancels out, moles of potassium carbonate cancel out with moles of potassium carbonate. All I have left is grams of potassium carbonate, and when I multiply through, I get 860 grams of potassium carbonate. Now, for both number 1 and number 2, you might be asking yourself, why am I rounding this way? And remember, it's all down to significant figures. So if you look at this problem, the number that was given to us in the problem started out with 2 significant figures, so my answer ends in 2 significant figures. My answer here, 6.2, or excuse me, my given in this problem has 2 significant figures, and so my answer only has 2 significant figures. Remember, this 0 does not count because there's no decimal there. Okay, so this is just a quick way of showing you how to do one-step conversions. If you need any other help with this, please let me know.